Hi everyone. Today we're going to talk about sequences, and in particular we're going to talk about what it means to be an arithmetic sequence. But let's just start with sequences first. So a sequence is a list of numbers that follows a pattern. So basically it's just a bunch of numbers, but there has to be a pattern to it. It can't just be random numbers. Now the pattern could be something really simple, like this one. 1, 2, 3, 4, 5, 6, 7. It's basically just the counting numbers. It can also be something kind of difficult or harder to see like this. So this sequence I'm showing you, if you're looking for a pattern, it might be kind of hard to see. This is actually a kind of famous sequence called the Fibonacci sequence. And basically the pattern is this. It starts with two ones in a row. But then after that, the next number is always found by adding up each two numbers. So for example, 1 plus 1 gives me the 2. 1 plus 2 gives me the 3. 2 plus 3 gives me the 5. 3 plus 5 gives me the 8. 5 plus 8 is 13. 8 plus 13 is 21, and so on and so forth. So you can see the first pattern was really easy to see, super obvious. If I ask you what the next number is in the first pattern, you go, it's 8. After 7 comes 8. That's easy. If I asked you what's the next number on the second pattern, you would have to first recognize the pattern, which was kind of tough, then realize what it would be as 21 plus 34 would be 55. Okay, now, when you're writing a series generically, kind of like a variable, we use the letter A to represent terms. So if I say A1, that means the first term. A is a term, and the number that comes after it, the subscript number, tells you which term we're talking about. So A1 means the first term in the sequence. If I throw another number in there, for example, A7 means what is the 7th term of the sequence, or A15 is the 15th term. So if I take the letter A and I put any number after it, like I said just a second ago, 15, that would mean the 15th term of the sequence. If I wrote out all the terms of this sequence, A15 is the 15th one in the list. Now, AN is a variable. That's going to be like our X for sequences. AN could be any term. It depends. It's like saying we don't know what term it is. It's AN. It's the nth term. That's going to be your variable. So basically our sequence goes A1, first term, A2, second term, A3, A4, A5, ... Eventually, somewhere in the middle is AN. That could be anywhere. And then I ended with another ... because the sequence can keep going forever. All right, we're going to come back to this notation, but first I want to talk to you about arithmetic sequences. Now remember, we said every sequence has a pattern. Arithmetic sequences are kind of like the easiest pattern. An arithmetic sequence is one where you notice the pattern is you are adding the same number each time to get from term to term, or subtracting, adding or subtracting the same thing. Now, before I continue on, I want to talk about that word arithmetic for a second, this word. You might look at that word and say, oh wait, that says arithmetic, like math. It is spelled the exact same way, but it's one of those words that's pronounced differently when you use it as a noun or an adjective. So if I'm talking about a noun, like a thing, arithmetic, meaning math, that's how you say it, arithmetic. But this is being used as an adjective. It's being used to describe the sequence. And when you use it as an adjective, instead of saying arithmetic, you say arithmetic. You pronounce it a little bit differently. So that's how that word is said. We say arithmetic sequences. And really remember what it means is the pattern of the sequence is that you are either adding or subtracting the same number each time. So in fact, the very first sequence I showed you today was an arithmetic sequence. The numbers 1, 2, 3, 4, 5, 6, 7, ... If you notice, the pattern here is you start with a 1, and then you're adding 1 each time. Plus 1, plus 1, plus 1, plus 1, plus 1, plus 1. The next one, 7 plus 1 would be 8. So basically that's the pattern. You're adding 1 each time. Now here's a second example. I started with a 12, and then it goes 5, -2, -9, -16, dot, dot, dot. Now the pattern here is that you are subtracting 7 each time. It doesn't really matter what you start with. I started with a 12 this time, but it's -7, -7, -7, -7. The next number would be -23, because I would have to add, or I'd have to subtract 7 again. But you guys get the idea. That's an arithmetic sequence, when the pattern is that you are adding or subtracting the same number to get from term to term, or from number to number. That's what we call an arithmetic sequence. Now we have a name for that number that you are adding or subtracting each time. It's called the common difference, and we use the letter D for it. So for example, also, D is positive when you're adding and negative when you're subtracting. So really, the way we really think of it, you're always adding. An arithmetic sequence means you're adding the same number each time, but when D is negative and you add a negative number, it's like subtracting. So you can think of it as adding or subtracting, but technically what it is adding a positive or negative number. All right, so for that first sequence I showed you guys, 1, 2, 3, 4, 5, 6, 7, if I ask you what is the common difference, very easy question, it's positive 1, or just 1. I'm adding 1 to get from term to term, so it's a positive 1. And for our second sequence, D would be -7. Because, and again, there's two ways to think about it. You could either say I'm starting with a 12 and I'm subtracting 7 each time, or you could say I'm starting with a 12 and I'm adding -7 each time, because that's the exact same thing. So D is the number that you're adding to get from term to term for an arithmetic sequence. It's positive if you're adding, and it's negative if you're subtracting. All right, now, the reason we're doing these arithmetic sequences right in the middle of Chapter 4 of Module 4 is because we're talking about linear functions right now, and an arithmetic sequence is very, very similar to a linear function, where basically the common difference is the slope. Because in a linear function, what you notice as you go through your x's, as you're going from y to y, remember we said you always add the same thing each time. Well, that's what we're doing with arithmetic sequences. We're adding the same number each time. So the common difference is like the slope. That's why we're learning this right now after we just finished talking about slope. And one of the things you guys are going to do in the homework today, you're going to find a formula for an arithmetic sequence. And here's what you can do to that. Here's what you can do. Here's what you can use to do that. So we have this formula, an equals a1 plus d times n minus 1. Let's go through and say what each thing is. Now remember, an, this is like our variable for any term. And what you're going to do is you're basically going to plug numbers in for n. If you want to find a10, plug in 10 for n. If you want to find the 100th term, plug in 100 for n. But an is like your variable, it's any term. Now a1 is the first term. So we have to know what the first term of the sequence is to be able to write our formula. Now d is d, that's what we just finished talking about, that's the common difference. And then you have n minus 1. Now the n from n minus 1 is the same n, that purple doesn't show up very well, let's try something better. The n from n minus 1 is the same as this n over here, which is basically your variable. And that's what I was saying earlier. If you want to find a100, the 100th term, plug in 100 for n. If you want to find the 10th term, plug in 10 for n. So it kind of depends on what you're finding, but that's the variable. So an is what we're trying to find a formula for. a1 is the first term, d is the common difference, and then n would be the variable. So let's try it out. We're going to find a formula for this sequence right here, and then use the formula to find the 20th term of the sequence. So this is what I have so far just by looking at it. Right here, -10, that's the first term, that's a1. Now, the only other thing I really need for this formula is d. So first of all, let's check and see if this is even an arithmetic sequence. So I'm starting with a -10, and I'm saying if I'm getting to from -10 to -2, that would be adding 8. That would be a +8. Let's see if it's +8 all the way. -2 plus 8 is 6, yes. 6 plus 8 is 14. 14 plus 8 is 22. So yeah, it looks like it is arithmetic, and it looks like D is +8. Now remember, those were the only two things I needed for my formula. My formula was AN equals A1 plus D times n minus 1. So I'll leave the AN for now. A1 is -10, that's the first term, I marked it in yellow up there, plus D is 8, and then you have the n minus 1. Now the last thing I want to do is clean this formula up a little bit. Let's do this. Let's take the 8 and do a distributive property. I'm going to leave the -10 for now. I'm going to do 8 times n is 8n, and 8 times -1 is -8. Now when you combine your like terms, we'll put the 8n in front. -10 plus -8 gives me -18. So there's my formula. AN equals 8n minus 18. Now if you think about it, remember how I said how similar this is to a linear function? That's basically like slope-intercept form, like y equals mx plus b, except instead of y it's an, and instead of x it's n. And that's why this is so similar to a linear function. Okay, now let's do the second part of this question. The second part of the question says find the 20th term. Now, what I mean is, if I'm not going to write it out, but if I took that sequence and I wrote out 20 terms, I kept going, okay, +8, +8, +8, +8, over and over, and I wrote out all 20 of those terms, what would the 20th one be? But we're not going to do it that way because now we have a formula. So if I take my formula that we just found, and I say I want to find the 20th term, that would be A20. Well, I'm using this just like function notation. I'm basically just putting the 20 right there for n. So I'm going to have 8 times 20 minus 18. And I do the multiplying first. 8 times 20 would be 160. And 160 minus 18 would be 142. So using the formula, I can figure out what the 20th term is without having to write out 20 terms. And 20 terms might not seem that bad. You might go, I could write out 20 terms, just add 8 20 times, that's easy. But what if I ask you to find the 1000th term? Then you definitely want the formula. You don't want to have to write out 1,000 terms just to figure out what the 1000th term is, when you can use this formula and just plug in 1000 for n. So what we did, just to summarize here, right here, we use this formula to come up with this equation based on our sequence. We put A1, the first term, that was -10. We put D, was +8. We cleaned it up a little and we found our formula. Then step 2, once we have the formula, we go, okay, I can find any term now. I can find the 20th term, that was 142. I can find the 100th term, I can find the 1,000,000th term. I can find any term I want now just by plugging in a number. You don't have to write out the whole sequence to do that. And that's what's good about that formula.